Chapter 12, Part 1. So we're going to move on to the spinal cord and spinal nerves. So the spinal cord extends from the foramen magnum of the skull down to the second lumbar vertebra. So the spinal cord doesn't go all the way down. However, there are nerves that branch off of that you can see here kind of look like there's all sorts of branching here. So the actual spinal cord ends above that. So there are segments of the spinal cord: cervical, thoracic, lumbar, sacral. Pretty straightforward there. It is important to remember that there are 31 pairs of spinal nerves that are branching off of the spinal cord itself. So you may be asked on the test how many spinal nerves there are, and keep in mind that spinal nerves are different than cranial nerves. Cranial nerves are nerves branching off of the brain. Spinal nerves are going to be branching off the spinal cord. So this cluster or all these kind of branches down here of nerves leaving the bottom of the spinal cord are referred to as the cauda equina. Cauda equina. And they're named basically because they look like a horse tail. And so you should remember that branching of nerves coming off the base of the spinal cord collectively are referred to as cauda equina. And equine, if some of you may know, that equine is referring to horses, so that's why they called it that. So meninges. Meninges are connective tissue coverings that are surrounding the spinal cord and also the brain. So you're going to hear me talk about those here, referring to the spinal cord, but you're going to hear me talk about these three meninges again when we talk about the brain. So again, they're connective tissue membranes covering the spinal cord and the brain. There are three: the dura mater, the arachnoid mater, and the pia mater. So the dura mater is the outermost layer. It's tough. It's thick. It's kind of like feels to touch it. At least the meninges on the brain is kind of thicker than even a trash bag is, if you can think of how thick a trash bag is, like a kitchen lining trash bag. The arachnoid mater is very thin and delicate. A lot of times in the preserved specimens, the arachnoid mater will not be visible because it just kind of disintegrates. The pia mater is closest to the surface of the brain and spinal cord. It is, when you look at close-up pictures of the brain, you might notice that it is real shiny. It looks like the thinnest of shrink wraps, kind of melted to the surface of the brain almost. There's spaces between the meninges, the epidural space, the subdural space, and the subarachnoid space. So you can read about these. I'm not going to spend a lot of time on those, but you should know that there are spaces between there. You're not going to have to identify the spaces, but there's a picture I included of the spinal cord with the answers on it in the handouts and the worksheets. So be familiar with that and be able to label the parts of the spinal cord using that handout that I provided in D2L. All right, so this is just another image showing you, if I don't know which, this is probably supposed to be a thoracic vertebrae, but you can see that space here for the spinal cord, and the spinal cord again, is in some places in the from top to bottom, it's no bigger than your thumb. And you can see how that's shaped in there. So just kind of something interesting. You're not going to have to label that, but Cross section of the spinal cord, we have an anterior median fissure and a posterior median sulcus. These are deep clefts that partially separates the left and right halves. So if you look at, I'll show you this one again. If you look at that, you can see that there's these little lines indicating in the center here. That's what they're talking about, are those clefts separating the right and left halves. White matter, I know I've talked about white matter. It's myelinated axons. They form tracts, and gray matter has neurons, cell bodies, cells, dendrites, and axons. And the spinal cord has a couple of different things indicating. We'll get into what these parts do later, but they're referred to as horns, and we have posterior horn, anterior horn, sometimes referred to as dorsal or ventral, and then of course the lateral horns. And if we look at these, basically these pointy things in the gray matter here are the tips of them, are the horns. So, but you'll see it better in the handout that I provided. All right. So cross section, more on the cross section of the spinal cord. Commissures, these are connections between the left and right halves. Basically, if you look in this picture here, see if I can find it. So these lines are hard to follow here. So you can see the gray commissure and the white commissure, and basically they're here and here. It's basically near the central canal, and then indicating where the white matter begins. So the roots of the spinal nerves arise as what they refer to them as rootlets. So they're little baby roots, and then combine to form the actual roots. And that's these here. It kind of looks like a rake. So you have these little rootlets coming out, and then they join to make the spinal nerves themselves. So we have the dorsal root and the ventral root. And we'll get into that when we look at the image that I provided again. The two roots actually merge laterally to form the spinal nerve. So again, you have the rootlets, the roots, the root, the rootlets, and then they join to make the spinal nerve. The dorsal root has a swelling referred to as the ganglion, and you should know by now what the ganglia or the ganglion means. We talked about that in chapter 11. All right, just another image. This is just an illustration, and this is an actual cross-section of the spinal cord. And, just a little side note here, these images to me throw me off because there's really nothing to compare the image to. So I remember as a student, I didn't really put it together how big the spinal cord was, but it is really, really small in some places. It's kind of amazing to me how, thinking that the one of the largest parts of your spinal cord is no bigger than your thumb. I don't know, for some reason that kind of blows my mind, but so relationship of sensory and motor neurons to the spinal cord. So we have dorsal root ganglion, again, those swellings here. It's where there's those clusters of cell bodies. And then the motor neuron cell bodies are anterior and lateral horns, are in the anterior and lateral horns of the spinal cord gray matter. Some of this you don't have to stress too much about. I know it's a lot of kind of random stuff, but I'll try to really focus the information that you need to recall on the overview worksheet or the review worksheet that I provide that covers like all the chapters for the nervous system. All right, so nervous system. I'm sorry, the reflexes. Reflexes are automatic responses. Basically, they are a survival instinct. Okay, we don't think about a reflex. It happens whether we want it to or not. And they say it's homeostatic, so it helps to maintain homeostasis in whatever, for whatever is happening. When we think of reflexes, most of the time we think of, you put your hand on a hot stove and you yank your arm back. And it's good that you didn't have to think about that, because if you did, you would have more injury on your hand otherwise. So reflexes are automatic and we don't think about them. It's not something that we, it isn't put your hand on the stove and go, that's hot. I should probably take my hand off. No, it's like your arm yanks back and you may, bump it into the person behind you because it's like this kind of quick reaction that you don't even think about. A reflex arc is basically the pathway that controls a reflex. And so you should make sure that you're aware of this, that the sensory receptor senses whatever the unpleasant stimuli is, and it carries that in a sensory neuron to the interneuron to the spinal cord. And then in most cases, it doesn't even make it to the brain. That interneuron is part of the spinal cord, which sends the information back out to the motor neuron to say, hey, take that hand off the hot stove. We don't have time to consult the brain for this. And then that motor neuron will activate, in this case, the muscle to remove the hand from the hot stove. So be familiar with a reflex arc, which is what is being indicated here. Basically, the steps, pretty straightforward, but it's the steps of what happens when a reflex happens. So there are some monosynaptic reflexes that don't include the interneurons. But generally speaking, whenever I talk about it, I always include the interneuron. And again, a reflex, I'm going to say most of the time, does not include any kind of brain control. Information is fed up to the brain after the fact, and then the brain continues on making decisions on what to do. But that initial, if we're talking about the hot stove, ripping your arm away from the stove is all spinal cord reflex. So here's an illustration of the reflex arc. Here's your sensory receptor going, ouch. That information flies down into the sensory, through the sensory neuron, carrying the sensation of pain to the spinal cord, where the interneuron makes a decision very quickly. Stuff is sent up to the brain, but the brain hasn't made a decision yet. And that spinal cord is like the trusted assistant that will send information back out via the motor neuron to, cause the effector organ to do its job, which is, in this case, the skeletal muscle. All right, so we're going to stop here and continue on with reflexes in part 2.